Hey everybody, this is John. Today I'm going to show you the electronics for my bullet feeder. I'm going to show you the schematic and explain how it works. I have two videos that specifically describe the mechanical construction of the bullet feeder. So as far as the electronics is concerned, inside this box is where the circuit board is. I have two sensors, a lower one and an upper one. And if you just turn this on, the red light will show you that the thing is powered on, and as the tube fills up, when you get to the top sensor, the motor will turn off. And now when you start loading again, this tube will start to empty, and the motor will not turn back on until the bottom sensor senses the tube is empty, and then it will fill back up, and the motor will stay off until the tube is empty again. I have the sensors here. They are mounted inside a little piece of round wood. So this is a 1/2-inch piece of tubing, and I just took a hole saw, and I think it was some MDF board. It might even be two glued together as a sandwich like that. And I took a hole saw and I drilled an outer hole, and then I drilled the inner hole, and I put some holes through the sides on each side there, and that's where I mounted the infrared emitter detector LED diodes like that. And I have a zip tie on the bottom and top here just so I can position the location of this guy for the lower one and the upper one. And if I want to move the position such that the tube will not empty as much before the sensors trigger, I can always just move the zip ties and move the position of the sensor with no problem. Another thing to note is that there are two LEDs, a red one which shows the case feeder is powered up, and then there's a green one. The green one illuminates to tell me that the motor is turned off because it has properly shut itself off because the tube is full. The green LED will stay on even as the tube empties, and the green LED will go off when the motor turns on. This is just to let me know that if the motor does stop, the green LED should be on, and if the green LED is off, the motor is stopped because of some problem like a jam or something like that. The bullet feeder motor is the same motor that I use in the case feeder. See that video for the case feeder electronics to see a bit of a discussion about the motor. For the sensor wires, I just use, so there's 4 wires to each sensor, 2 for each LED, and the wires, I just use phone jack wire for that. And the sensors come back here, and the wires enter into the box in the back, and then this is just the jack for the 12-volt adapter. This is just an aluminum project box I got at Radio Shack. If I take the front cover off, this is what you have inside. The 2 LEDs mounted in the front. I use a little switch here, position switch for different speeds, and that's the circuit board in there. It's a perf board, voltage regulator, and a bunch of transistors. I put a fuse on there, which is not really required. A bunch of resistors, transistors, stuff like that. That's what it looks like. Everything we're going to talk about is actually inside this box here. This is the power supply regulator that I use. I explain this in my other videos, case feeder and or low primer warning alarm video. So go to those videos and check those out for information on that. But essentially this is the LED, the red LED that we have on the front of the box to show us that it is powered up. And this would be the switch, and this would be the voltage regulator, and these are resistors that set the voltage regulator output to 12.3 volts, or around 12 volts to power the circuit. This is the electrical schematic for the circuit that drives the motor. This 12 volts here, this represents that voltage regulator circuit that I showed you a second ago, and this is where it connects on. We have the bottom sensor, which is at the bottom of the tube. And then we have the top sensor, which is at the top of the tube. This here circuit is sort of a circuit that will hold the previous setting I'll explain that to you in a second. This capacitor, along with these two PNP transistors and this resistor, this here only comes into effect and is used at the instant that you turn the power button on and the thing starts up. This does something to put the circuit in an initial state such that it will make the right decision whether or not to turn on the motor based on the two sensor settings. This capacitor over here, the purpose of this guy is to slow down the response time of the top sensor, because if the bottom sensor is filled up and the top sensor is not, and the motor's turned on, as the bullets drop down through the tube, they're going to pass right through that top sensor. If that top sensor can pick up the falling bullet, it will think that the tube is full and turn the motor off. So the purpose of this capacitor is to slow down the response time such that a falling bullet won't falsely trigger that top sensor and turn the motor off. We have this NPN transistor and this green LED diode. This is the one on the front that says that lets you know that the motor's turned off because the tube is full. This NPN transistor here is just a current booster. This transistor will get a voltage from this wire, current will flow into this guy, it will get amplified, boosted up through this guy, and that current will then drive into this guy, which will get boosted up again, and then this guy will control to turn on or off the motor. There is a diode here. The operation of this diode with the motor, I covered that explanation in the case feeder schematic video, so check that one out. As far as the transistor working to boost up the current, I also cover that in the case feeder video, so check it out if you want to know how these transistors work to boost up the current. This resistor here, I don't have the actual value in my kit, so I use 3 resistors in parallel to come up with the value of 187 ohms. It's basically 560 ohms divided by 3. All the transistor NPN transistors, which are transistors with the arrow pointing outward, those are all NPN, and they use 2N3904 transistors for that. The PNP transistors, which are these guys, they use 2N3906 part number transistors. All the transistors is either those or this one. It's one or the other. There's no other brand or flavor or part number transistors than that. The top and bottom LED infrared sensors, they come from Radio Shack, part number 276142. And all the resistor component values are like 10 kilo ohms, 10,000 ohms, 187 ohms, 10 microfarads for the capacitor, 57 microfarads for the capacitor. And these are all standard components you should be able to get at Radio Shack or on eBay or something. The motor comes from Allelectronics, part number DCM276, 5 RPM 12 volt motor. So this is the same schematic again, except what I've done is I've replaced the transistors with the top down view of the actual transistor components. See my slide that shows you the transistor orientation. There is a flat side, and by looking down, for example, you would plug the transistor straight down like that to set this guy up. Likewise, this one would be straight down like this. The infrared LED diodes, they have a flat side as well, so the clear white one would be flat side up, dark one would be flat side down. The capacitors, they are electrolytic capacitors, so they are polarized. There is a plus and a minus. The side with the stripe or the black markings or something, that would represent the bottom plate or the curved plate. That's the negative, so you have to make sure that you put those in correctly. Again, see my other videos, I describe that a bit more in detail for the capacitor. So now let's describe how this thing works again. The circuit has different states of operation. Condition 1 or state 1, condition or state 2, which is a hold state, state 3 or condition 3, and state 4, which is state 2, which will hold. So let's quickly go through this. I'll explain it to you. You have the top sensor and the bottom sensor, and the top sensor will come into the circuit. This would be that Q wire that we saw, and bottom sensor would be the QB wire. QB and Q are always opposite, where if Q is 6 volts, QB is going to be 0 volts. If QB is 6 volts, Q will be 0 volts. So one is always the opposite of the other. When you first turn the circuit on, if the tube is completely empty, the motor will turn on That is called state 1. Once the tube is partially filled, now the bottom sensor is going to be full and the top sensor is still going to be empty, but the motor will keep running until the top sensor is full as well. So this is going to be called state 2, but it's state 2 is just holding state 1. Then we've got state 3, and that is the bottom sensor is full and the top sensor is full. At state 3, another decision is made to turn the motor off. Now we have state 4. So we've started to run the machine and the bullets start to come out the bottom, and now all of a sudden the top sensor is no longer full, it's now empty, but the bottom sensor is full. So now the machine doesn't make a decision, but we're at state 2 again, but this time state 2, as the tube empties, state 2 will now hold the motor off. So state 2 is sort of this, it's not a decision making state, it's sort of a state that's a hold state. So the reason for the startup circuit, that's 2 PNP transistors with the resistor and capacitor, I have that there to, when you first power the circuit on, you want to make sure that it powers up in state 1. Because if there's a couple bullets in the tube and you first turn the power on at the beginning of the day, what's going to happen is that the tube will not just fill up, it will stay, the motor will stay off until you run all the bullets out, and then the motor will kick in and turn it on. I wanted it such that when you turn the power on first thing, the tube will fill up. So that's the purpose of the PNP transistors. So that's the description of how the circuit works. Now I'm going to show you how the circuit does this. So if you've been having a good day and you're not confused and you don't have a headache and you want to stay that way, I suggest you stop the video now. So I see that you've decided to get a headache. Well, let's get started. So condition 1, we start off, the tube is empty. I've removed the PNP transistors and the capacitor stuff and this capacitor that slows down this sensor because it doesn't really apply for the analysis. So the motor is running, which means this guy is turned on, which means we've got 6.3 volts here. This top sensor is empty, the bottom sensor is empty. The bottom sensor pulls this node near 0 volts. And what that does is it also turns this transistor off. So this transistor is out of the picture, it doesn't even participate. This top sensor over here also pulls this node low to 0 volts. So this transistor is also out of the equation. So you can think of these two transistors are gone. So all we've really got then is this resistor and this stuff that's down here. So with these two transistors, pretend they're gone, you're going to have some current flow down through this guy, and that current will flow down this wire and into the base of this guy, turning this guy on. And so the little bit of current that you got flowing down here, that's why you've got some, if this is 12 volts, you've got like 5.7 volts drop across this guy. That's because you've got some current flowing through here down to this guy. You've also got some current flowing this direction into the base of this guy. Also note that because this is 6 volts and this guy's turned on, this transistor also tries to pull this node to 0 volts. So you got this guy pulling this wire to 0 volts by pulling current through this guy, and this guy also reinforces pulling this node to 0 volts through this guy. So you got this and this acting to make 0 volts. Because this node is 0 volts, this transistor is off, the green LED is off. So condition 2, the tube has been filled up now, the bottom sensor is covered up, it's full, the top sensor is still empty, the motor's still running, so we are now still holding condition number 2, state number 2, which is holding the motor on. Now in this condition, we don't have the little red arrow here anymore, so this sensor is now turned off. In state 1, this sensor here was pulling this node, this wire to 0 volts, and this transistor being turned on from this voltage was reinforcing and helping this guy pull it to 0 volts. But now in this condition, where we're in the hold condition, this sensor is out of the picture. It's doing nothing. But this transistor is still turned on. So before it was reinforcing and helping maintain the 0 volts, now it's the sole provider which is drawing all the current down to make the 0 volts. So this guy is holding state 1. So all the circuit voltages and everything that was going on in state 1, now in this state 2, which is holding state 1, everything is the same except this sensor is out of the picture. And this guy is doing the work. So now state 3. The tube has fully filled up and the top sensor is now full, just like the bottom sensor. So a decision is made again, which says turn the motor off. So now you can see there's no red squiggly line here or here. That's because this sensor is off and this sensor is off. No light is passing through, right? Because the beams are broken because the sensors are full. So you can imagine these two sensors are completely out of the picture. Ignore them, forget them, they're done. So with this out of the picture, there's now nothing drawing current through here that will pull this node to 0 volts. So instead, some current will flow through this resistor and will flow down and into the base of this guy. Now enough current flows through this resistor. This diode voltage, or the 0.7 volts across here, I've explained this in the case feeder video, why this is 0.7 volts. This guy turns on, so this guy will now pull current in here. It will pull it through this resistor and it will pull the voltage here very low down near 0 volts. So what that does is that will turn this guy off. And this guy, because this sensor here is also turned off, there's nothing pulling current in this direction. So this voltage is now higher. It's not like 12 volts. It's still lower, like 4.85 volts, because there is some current flowing through here. And that current flows down through here and into this base of this transistor and turns on this green LED to show you that the tube is full and the motor's off. So this voltage is high. Enough voltage that we get current flow down here and into the base of this transistor that turns this transistor on. So we've got 0 volts here from two things. One, this transistor is on, it pulls current into it, which pulls the voltage on the node down from here, drawing current through here. Also, you've got this transistor on from this voltage over here, which reinforces the 0 volts. So you got this guy, and you got two things helping make 0 volts here. And because this is 0 volts, no current will flow down here into the base of this guy. So this guy is not turned on, it's off. And therefore no current will flow into here, and this guy will be off and the motor will be turned off. So now we've got the last state, which is state number 2, holding condition 3. So the motor's turned off. Now the top sensor is no longer full. It's empty again, but the motor is off because it's being held off because we're holding state 3. So now in this state, the top sensor is now empty again, so we're getting signal come through here. This signal is causing current to flow down through the sensor, pulling this voltage low, so it turns this transistor off. And this transistor is out of the picture, it's not drawing any current. But we've got 0 volts here because this transistor was helping support pull the 0 volts down because it had current flowing through it as well. So before it was just helping reinforce 0 volts here by drawing current. This time, with this guy turned off, now it's the primary thing which continues to maintain the current flow down here to maintain the 0 volts here. And that's why we're still holding 0 volts here and we're still holding the motor turned off. So we get no current flows here. So this guy also stays turned off. So this node is still high because this sensor is still turned off and out of the picture. So this node is only 4.8 volts, not 12, because this green LED is still turned on. So we still have some current flowing through this resistor down here into the base of this guy with this guy turned on. So that's why you got 4.8 volts, because you got current flowing through this resistor. The LED is still on, transistors are still off, and the motor still turned off. So this is the original full schematic again. Now I'm going to explain to you why we need this capacitor, this resistor, and these two transistors. for the initial startup of the circuit. So the goal here is when we first turn the power on, if the top sensor is empty and the bottom sensor is full, which means the bottom sensor is out of the picture, but this guy here is fully on. When we turn the power on, we want that motor to turn on to fill up the tube. I've drawn here without the startup circuit to show you what happens if we didn't have it. So we've got this capacitor that I said is to slow down the response time of this sensor to prevent false triggering of the top sensor so we don't turn the motor off as the bullet falls through that top sensor, and so it won't pick up the falling bullet. When you first power up the circuit, this capacitor is not charged up. Now capacitor, think of a capacitor as like a camera flash. You turn the camera flash on, and after a minute or so it charges up, and then it's ready, and you press the button, and then you can release all of the energy that's in the flash in the form of light, right? Well, a capacitor is sort of like that. You've got to charge it up. But with the power turned off, the capacitor is not charged up. So you got to think of everything as the very split instant and when you turn the power on. The instant you turn the power on, you're going to have 12 volts here. The capacitor is not charged up. What's going to happen, this may not be intuitive, but because the capacitor is not charged up, the capacitor is going to force 12 volts to be here. So even though this sensor is turned on, it's drawing current down this way, and it's going to try to pull this node to 0 volts. The very first instant, the second the power comes on, the capacitor is going to force 12 volts here. And then after a very short interval, this guy here will pull all the current out and charge up the capacitor to 12 volts. So what will happen is the voltage on this wire will go from the initial 12 volts imposed by the capacitor, turn to 0 volts. So the voltage right here will start out as 12 volt and it will slowly go down to 0 volts. But that very beginning instant when this is 12 volts, it turns this guy on. It will draw current here through this resistor, and that will force 0 volts to be here on the very instant the circuit is turned on. What that does is that turns this transistor off. This side of the picture, it means you've got high voltage here, current flows through this resistor, turns this guy on to help sustain the 0 volts. And with 0 volts here, the motor's off. So what that means is with this capacitor in place, as soon as you turn on the power, you're always going to resort to that state number 2, but holds condition number 3, which is motor turned off. We want it to be the other way around where you're holding condition 1. So how do you do it? Well, we put that PNP transistor stuff in. Capacitor's in place. We flick the power on real quick, 12 volts here. Capacitor's not charged up, so capacitor will impose 12 volts here. This guy here has a signal, so this guy is going to try to pull this voltage down. Over the first split instant, you're going to go 12 volts down to 0 volts. But you still got the 12 volts from the very beginning imposed by the capacitor. Now, we've got this other capacitor right here. This other capacitor is not charged up from the beginning, so it's 0 volts across it. So you've got this resistor up here, and when you put a resistor with a capacitor, it takes longer for that capacitor to charge up. It's like trying to charge up your camera flash with a dead battery or a very weak battery, right? The resistor will restrict the amount of current that flows in to charge up the capacitor. Because it's restricting it, it charges up the capacitor a lot slower. So the minute you've got the 12 volts on applied here, this capacitor is going to have 0 volts across it. So the voltage on this wire here for the beginning instant is going to be 0 volts. But then over time, as this capacitor charges up, it charges up towards 12 volts. So that's why we go from 0 volts to 12 volts over a short interval. So that beginning interval, when you get 0 volts here, that's going to turn on this PNP transistor. And this guy will turn on this PNP transistor. And with these two guys turned on, it will connect this wire to this wire. So for the very first instant in time, these transistors are going to put 11 or 12 volts on this wire here. So even though all this turns this guy on right from the beginning, and this guy tries to draw current to bring this to 0 volts, these transistors are going to put in enough current to this node that this is going to be high, 11 or 12 volts. What that does is, from the initial state, this wire here will be 11 or 12 volts, turns this guy on. And that will, even though these guys are turned off, this guy will draw current, turn this node to 0 volts, and then this guy is no longer the reinforcer, it is just the full enforcer to pull this node to 0 volts. So 0 volts here, no current flows in here, So this guy's turned off now. So this guy won't pull any current down to pull this node low. This will go from 11 volts from the beginning, because there's no real current flowing here, but it will go from 11 volts, it will decay down to around 6.3 volts because the motor is going to be turned on. This is going to be high. We're going to have some current flow here into this guy. This guy is going to boost up that current, drive it into this guy. This guy is going to be turned on from the current, and it's going to boost that current up and turn the motor on. The current that flows down here comes through this resistor, and that's why this node voltage here goes from like 11 volts down to 6.3 volts, because when the current starts flowing down here, it flows through this resistor, and that's why the voltage drops from 12 volts to 6.3 volts. So this circuit from the very beginning, what it does is it turn all this stuff on such that it will put us in condition number 2 holding state number 1. And that's why when we turn the knob, if the tube is half full, the motor will turn on and fill up the tube.